Saxon Algebra 1, Lesson 89. Greetings, students. It's the beginning of week 24. 24 weeks we have been at this Algebra 1, and we're making great progress. Lesson 89 is one that is slightly familiar to you. I might name this lesson, if I was coming up with my own names, I might name it coin-ish problems. Remember how when we first started talking about coin problems, I told you that the first thing we do in coin problems is we set up an equation that talks about the quantity of coins, right? Not what they're worth, but how many we have of each particular kind of coin. And then we write a value statement that multiplies how many we have times how much they're worth. And those two equations together create the system that we then solve using either substitution or elimination. We've learned both. We also learned that we can solve a system of equation by graphing, but we're not going to use that in problems like this. In this lesson, John does not tell us whether to use substitution or elimination. It's our choice. Yay. So I will choose. If you were with me and could talk to me right now, I would let you choose. But I will choose, and then I will tell you what my thinking is, and then you get to choose for yourself. So there are two problems. Let's read the first one. Airline fares for flights from Tifton to Adele are $30 for first class and $25 for tourist class. Now let's just stop and think about what it would be like if you could get on a plane nowadays and fly for regular, like coach is what they mean by tourist class. Different airlines call it different things. But a basic ticket is $25 and first class is $30. I mean, wow, that would be amazing, wouldn't it? If a flight had 52 passengers who paid a total of money, how many first class were on the trip? Okay, so what we can see is that instead of having like the number of nickels, the number of dimes, in this example, we have first class and we have what they call tourist. Okay, the total number of passengers is 52. If a flight had 52 passengers. So that means that the number of first class passengers plus the number of tourist passengers equals 52. That is our quantity statement. Now we have to take the amounts that the tickets cost, the prices, and use those to create our value statement. First class is $30. Tourist class is $25. Again, I want to go for a ride on that plane. So now we're going to take 30 and multiply it by the number of first class. And notice I chose, you don't have to, I chose to put 2 letters in my subscript. You can do that if you want, first class. I could have just put the F. I could have put 1 for first class and 2 for tourist. You can do it however you want. Just make sure it makes sense to you. Plus $25 times the number of tourist tickets we sold. And then John tells us that that total is 1360. And this makes sense because if you take the number of people flying first class and multiply it by the price of a first class ticket, and then do the same thing with the tourism tickets, tourist class, number of people flying in that class times the price, add those two together, that should be the total amount of money they collected. Notice we don't have to make any adjustments because all of these things are stated in dollars, right? There's no cents that we have to adjust for. So that makes this a little easier. I would also say this is kind of an old-fashioned problem because on most flights now, right, tickets come at so many different price points depending on when you buy it, depending on which seat you buy. There's way more than just 2 different prices. So this is kind of a cute little old-fashioned problem when life was simpler. All right, so now what we want to do is figure out how we want to solve this. Now, we can do it any way we want, substitution or elimination. What I'm going to choose to do is I'm going to do substitution. The reason I choose substitution is because I can easily rearrange this to get one of the variables by itself. I'm going to choose to subtract this one to the other side, and then I'll have NT equals 52 minus number of first class. Okay? Now I'm going to substitute this into this. So here's one NT, here's the other NT. So this will become 30 times the number of first class plus 25 times 52 minus the number of first class equals 1360. That had to get skinny. Okay. All right. Beautiful. Now I have a little multiplying to do. Well, let's see. This is the same. 30 times the number of first class. Here's my distribution, right? This, all right. 25 times 52. Let's see, 25 times 5. I'm just going to do it right here. 52 times 25. So that is 1300, right? I just did a little multiplication side break there. Some students don't like to clutter up their problem pages, their homework pages with these icky little calculations. Make a little box around it, create a little work area on your page if that bothers you so that it kind of is set off to itself. But do not be afraid to make these calculations, they're necessary. Minus 25 times the number of first class equals our 1360 again. I can combine like terms, and at the same time I'm going to subtract this 1300 from both sides. That's going to whittle my numbers down to a much more manageable thing. These two go together to make 5 times the number of first class. That cancels, and this equals 60. So the number of first class passengers, we'll divide both sides by 5, right? Equals 12, and that means the number of tourists must be, let's see, they have to total 52, so this must be 40, because together they equal 52. And here is my answer box, and that is the right answer. So my takeaway for you is that in these problems, these value problems, like our coin problems, we will be setting up a system of equations. One will relate to quantity, one will relate to value, and then we get to choose either substitution or elimination to solve. All of that is familiar. The only thing that's new and different is these stories are just a little, you just have to embrace the weirdness of them. They're just a little bit different. Okay, one more problem and we're done. That's exciting, right? Example 88.2. No, 89, sorry. This is the one about the dress shop. There's one about a fishmonger that comes up later that I can't wait for. Wataksha is the name. Wataksha's dress shop sold less expensive dresses for $20 each and more expensive dresses for $45 each. Okay, so those are our two variables. There's the less expensive, and there's the more expensive. I'm gonna put stars so they don't look like minus signs. And the less expensives are $20, and the more expensives are $45. So I know that the number of less expensive dresses plus the number of more expensive dresses sold, we don't, oh, okay, here's what it says. The number, it sold more of the less expensive dresses than the more expensive. So I got excited and I started writing this, but this isn't the way we're gonna write this one. There were more of the less expensive dresses sold. So that's what I've got. The number of less expensive dresses is more than, it sold more of the less expensive dresses than the more expensive dresses. Oh, the number that balances them is 20. So I'm gonna add 20 to this side because this is the smaller side. And then that will turn it into an equals. That's really tricky wording. They sold 20 more of the less expensive dresses than the more expensive dresses. That means they sold more or less than more expensive. It's so confusing to say. So we add 20 to the smaller size. So that's our quantity statement. Now we have to write our value statement. So we know that 20 times the number of less expensive plus $45, sorry, I got distracted, by the number of more expensive equals the total amount of money they got, which is 1375. Now, I have a system of equations. This talks about just the number of dresses. This takes into account their price and the amount of money we collected. Beautiful, I'm good to go. Now, this time I see, oh, this one is already set up for substitution. So this one I'm definitely gonna substitute because it's already written this way. Thinking about that, when I look back here, I think, you know, I could have easily chose to eliminate this and multiplied this top one by like minus 25 or minus 30. That might have been a more logical way to do that one, but I didn't. I chose to substitute. But now I'm gonna choose to substitute for sure because this one is all set up. But again, as I told you way back at the beginning, the day has come when you get to choose how to do that. So here's one variable, here's the other one. I'm gonna substitute this into this place. 20, right? Beautiful. All right, let's distribute and see what we get. Now remember that as I'm choosing substitution, I'm doing it just based on the shape of these, and then I just start substituting. I don't have a plan for how this is gonna work out. I know that if I work correctly, I'm gonna eliminate one variable and just solve for the other one, but I don't plan out ahead of time which one it's gonna be. I'm kind of stepping into this blindly. I'm trusting that I know how to take these equations and substitute them into each other to get a good answer, but I don't know what shape that answer is going to be. I don't worry about it. I just go ahead and work the algebra. So that's what I'm doing here. I'm not worrying about what I'm gonna end up with. I'm just going step by step, making sure that I'm not making any little mistakes and trusting, whoops, trying to copy the numbers correctly. I was thinking about that 400 because that's gonna get subtracted over there, isn't it? That's my next step. And then I'm gonna add these like terms. This cancels, I get 65 times the number of more expensive dresses equals 975. Oof. I'm hopeful that that number will go into that evenly, but boy, it looks rough, doesn't it? So, let's see what happens. 975, 65. 65 into 9, no, that doesn't work. 65 into 97, just once. 3, oh, this should be a 5. Good heavens, I'm having a hard time with that one, aren't I? 325. Well, I'm gonna guess. Okay, I think to myself, so how many times does 6 go into 32? 6 times 5 is 30. I guess I'm gonna try that because I want this to end up as a 5. 5 times 5 is 25. Oh, look, there it is, 30 plus 2, 32. So, the number of more expensive dresses equals 15. And then the number of less expensive dresses, and I always go back to my quantity statement because that's usually the easiest. The numbers are the easiest, right? Because they don't have anything being multiplied in front of them. This equals, I take this number of more expensive, and I add 20 to it. So this is going to be 35, right? The number of more expensive plus 20 equals the number of less expensive. So I add 20 to my answer. That's correct. Yay, team. What I hope is that these problems make you feel really smart because they are fairly familiar, and with just a little bit of subtle nuance in the way the story is written, we get new problems that feel slightly different but are really quite similar to our coin problems, which is why I would call them coin-ish problems. Lesson 89 is done. Yay. Thank you. Goodbye.